Welcome to page replacement algorithm. So in the previous lecture we have seen the FIFO, that is first in first out page replacement algorithm. And what is the problem with that first in first out page replacement algorithm, that is Baladi's anomaly. Adding a more number of frames can cause the more page faults. So to overcome this problem we are using the optimal page replacement. It is the one of the best algorithm or efficient algorithm which is going to produce the minimum or optimal number of page faults here. So now how we are going to implement this algorithm? We are going to replace the page that will not be used for the longest period of time. So here we are going to implement this algorithm by using this method or this step. So now we will consider the same example, which is that we have taken for the first in first out. That sequence is 7 0 1 2 0 3 0 4 2 3 0 3 2 1 2 0 1 7 0 1. We are going to consider the same sequence with the same number of frames, that is 3 number of frames, 3 frames we are going to consider. We will start with the implementation of the page replacement algorithm, or how it is going to be used, by considering this example reference string. So we will start with 7. The number of frames in the physical memory is 3. So at the beginning 7 there is no pages in the memory, all the frames are free. Simply what you do, bring that page into the memory. Bring page number 7 into the memory. Go to the next sequence, page reference string is 0. Again there is a free frames, load or bring 0 into the memory. Go to the next sequence, 7 0. Again there is a free frame, load that into the memory. Go to the next sequence, 2. Now verify is this page is there in the memory, that is not in the memory. So now we are going to replace optimal page replacement. You are going to replace the page that will not be used for the longest period of time here. So means we have to predict the future thing. So now which page you are not going to use for the longest time here? The page that is 7. See the figure or see the sequence. 7 is the page that is going to be not used for the longest time, that is going to be replaced here. That 7 is replaced with what number here? 2. 0 and 1 will be as it is here. Now again there is another page requesting, demanding here 0, that is there already in the memory, there is a no page fault. Now go to next sequence here, 3. Now 3 is not in the memory, again there is a page fault. We need to go for the page replacement because there is a no free frames. Now which page you are going to replace here? Now again verify the page that is not used for the longest time. So followed by 3 we are using 0, but the 1 is not used for the longest time. So now 2 is also used in between here. So 2 will be as it is, 0 will be as it is. We are replacing 1 that is not used for the longest time. This is removed out and the page 3 will be bring into the memory. Now next sequence is 0. 0 is there already in the memory, there is a no page fault. Refer it and execute the code. Next reference string is 4. There is a no page in the memory. Now check out which page is not used for the longest time. Followed by 4 we are using 2. We are also using 3. So 2 and 3 will be keep as it is. We are going to replace 0 here now. 4 is we are replacing 0 with which reference string here? Page number 4. And 2 and 3 will be as it is. Go to the next sequence, 2. It is there already in the memory, there is a no page fault. Go to the next sequence, 3. It is also there in the memory, there is a no page fault. Go to the next sequence, 0. Now there is a page fault. Now verify which page is not going to be used for the longest time. 3, 2 are using here. In this future sequence there is a page 4. Page with a reference string 4 is not used anywhere here. Now we are going to replace 0 with a page 4. Okay, sorry, 3 will be as it is. Now next sequence is 3. It is not going to be there is a page already in the memory, there is a no page fault. Go to the next sequence, 2. It is also there in the memory, there is a no page replacement. Next sequence is 1 here. So in this sequence you just verify which page is not used for the longest time. Now we are replacing which page here? Now we are replacing which page here? 3. 2 is also required, 0 is also you are using in the future, 3 is not used in the future. Now the 3 is replaced with the page 1. Again go to the next sequence. Next page, demand page is 2, it is there already in the memory. Next demanding page is 0, it is also there in the memory, there is a no page fault. Next demanding page is 1, this is also there in the memory. Go to the next sequence 7, just verify it is not there in the memory. Now which page you are going to replace? So now we are going to keep 0 and 1 as it is. 2 is not used in the future, will be replaced with a 7, and the remaining strings 0 and 1 will be as it is. Now next sequence is 0, it is there already in the memory, there is a no need of page fault, will be not raised. 1, demanding page 1 is also there in the memory. So next there is a no pages in the sequence, we are going to stop the algorithm. So this is how we are going to implement the page replacement algorithm. Which page replacement algorithm here? Optimal page replacement algorithm. So the number of page faults are see just 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 page faults are raised here. Compared to previous one, in the first algorithm we have considered the same reference string, there are 15 page faults, and here it is a 9 page faults. Compared to that, optimal page replacement is efficient and flexible. But what is the problem here? So prediction of the future thing. So how to predict or how to know which page is not used longer time in the future? That is going to become a complex with optimal page replacement algorithm, and that is only one problem. The other thing is going to means the number of failed spots are less here.